Okay, let's review everything we know about the moon for the upcoming test. We're going to use this diagram to help review for this test everything we know about moons. We know that the sun's rays are coming in straight and that the sun is quite far away and that often these diagrams are not drawn to scale. The sun is drawn too small in comparison to the Earth. We know that the moon revolves around the Earth, and it takes about 28 days for it to revolve all the way around the Earth. There are four main moon phases as the moon revolves around the Earth. Okay, the first main moon phase is the new moon. Okay, so the new moon is going to be all dark, and the full moon is all lit. They're in a straight line, either in between the sun and the Earth or on the opposite side. Okay, these are important when it comes to tides because they're associated with spring tides, the highest high tides and the lowest low tides. Okay, these moons right here are the first quarter and the third quarter. Okay, we call them quarter moons because they're a quarter of the way around the Earth, even though they appear to be half lit and half dark. Okay, so let's remember that we're talking about every quarter of the way around is 7 days. Okay, so every quarter of the way around on this. These quarter moons are associated with neap tides. Neap tides are the lowest high tides and the highest low tides. The spring tides occur because you have the sun and the moon working together to make their tides either higher, the highest high tides, or the lowest low tides. The neap tides occur because you have the moon, and the sun working in opposite directions, right angles. We can divide the moon's journey around the Earth into two main sections. The first is as the moon is getting more and more lit. So as the moon is going from a new moon to a full moon, we call that part of its journey waxing. So the moon is getting more and more lit. Remember that the light starts appearing on the right side until it is full. The second part of its journey is waning. Okay, and that's the journey from a full moon back to a new moon. So we refer to that as waning. The moon phases surrounding a new moon, where just a little bit of light is beginning to appear on the right side, or just a little bit of light remains on the left side, are known as crescents. The moon phases surrounding the full moon, where a little bit of light, or just a little bit of dark still remains on the right side, or just a little bit of dark remains on the left side, these are known as gibbous. So now you can see that we have a full description of the moon phases around the Earth. Okay, now we have a much better filled out diagram for the moon phases. Remember that for the moon to travel all the way around is 28 days. So if it takes 28 days to go around the entire revolution, how many days would each quarter be? So we would know that each quarter was 7 days. So to go a quarter of the way around is 7 days. 7 days from there, 7 days here, 7 days here, 7 days here, for a total of 28 days. So we can ask a lot of questions using this knowledge. If it was a new moon, what type of moon phase would it be in 14 days? 7 days? 7 days? It would be a full moon. If I give you a calendar date and I said that it was November 10th and it was a third quarter, what would the moon phase be on November 17th? From November 10th to November 17th, that's 7 days. 7 days would bring me to a new moon. If I had a waxing crescent, what would the moon phase be in 7 days? In 7 days, I'd go a quarter of the way around, it would be a waxing gibbous. If I had a waning gibbous, what would the moon phase be in 14 days? 7, 14. It would be a waxing crescent. How often does a spring tide happen? So we have a spring tide at a new moon, 7, 14 days till we get to our next spring tide. So we have a spring tide every 14 days. A lot of students hear the name spring tide and they think it only happens in spring, but that's not true. Every 14 days we have a spring tide. How long would it take to go from neap tide to spring tide? You can see here that it would be 7 days to go from a neap tide to a spring tide. All right, let's talk for a moment about tides. Tides are caused by the gravity of the moon pulling on the water on Earth. And it pulls the water just a little bit closer to the moon. So sometimes we'll draw a bubble like this so we can see where the high and low tides are. So we see that the moon is here, we have a bubble on either side of the Earth. And this is where we have a high tide. And on the 90-degree angles we have a low tide. You can see in this picture here, this is what the water looks like at this dock during high tide. But during low tide, the water recedes and goes back out, and there's much less water. Okay, so we have high tides and low tides. So how often does a high tide occur? Well, we know that it takes 24 hours for the Earth to rotate around. So if we look where North America is, we're going to start rotating it around. And let's count how many high tides it goes through. So there's 1, still rotating, 2, and now we're back to our original position. So in 24 hours, it went through 2 high tides. It also goes through 1, 2 low tides. So every 24 hours, you have 2 high tides and 2 low tides. One final question that you may be asked on the test is if the moon was in this position, what would it look like from Earth? We talk about these as a Blue's Clues question because we came up with the Blue's Clues method for solving them. There's a whole other video that helps to explain that, but we're just going to summarize it here. First thing we're going to do is we're going to darken in the half of the moon that is not facing the sun. Obviously the half of the moon that is facing the sun is lit. Next you're going to turn the paper so that it is your belly button, the Earth, and then the moon. You're going to imagine yourself shrinking in and looking at the moon from Earth. Now, if we look to the left-hand side, you notice that it is lit. Now, in this case, this is one of those 4 special moons. The middle line is the line, and the right line is dark. We're going to remember that it looks like light, line, dark. Light, line, dark. So we know the right side is dark. That makes this a third quarter.